All right, welcome to video 1-6. We're going to be talking about the equation y equals mx plus b, which is more formally known as a slope-intercept form, because those are the two things you need to make that equation. You need a slope and a y-intercept. Sorry if you sat through the last video and wondered what all that tapping was. I didn't use my microphone on that one, and apparently it created a really loud noise every time I touched the iPad, so sorry about that. I won't make that mistake twice. So in this learning objective 1-6, all about this equation right here, which is the equation that we use for trend lines, which is what we've been talking about a lot in these videos lately. So what is a trend line for, though? What is the purpose of all of this? Well, a trend line is really for two things. The first thing, which I'm going to highlight orange on here, is called interpolation. Interpolation is all about making predictions within the range of the data. So to look over here and to highlight orange, think about my highest data point is right about here, and here's sort of the x value of my highest data point on the trend line. And so all this area in here, I could make predictions about any of these x values or any of these y values and call that interpolation. Whereas if I was making predictions about y values that were higher than that, or x values that were higher than that, then I'd be doing a different process we call extrapolation. Basically, extrapolation is kind of like predicting the future in some sense, or doing things that we have not yet done. It's a really important, outside of the data range, it's a really important part of scientific theories, is the fact that if a scientific theory is good, if a model is good, like if this is the right trend line for this data, then we can use it to predict things that are happening at much bigger scales or much smaller scales than what we're actually testing in the lab. So if that's what an equation is for, if it's for making predictions, and in this class that's going to be useful when you're completing your challenges, like the Spaghetti Bridges challenge, how do we make an equation? Well, we need a couple things. First, we need the slope. We've had a couple videos now on slope, so if you don't know how to find slope, please go back to some other videos. The other thing you need is the y-intercept, and we've talked about y-intercepts in other videos, but I haven't gone into much detail about it. So let's take a second just to think about that. So the y-intercept is found by looking at the y value when the x value is 0. So if you look at these graphs, x is going to be 0 right here. That's the point where x is 0. We call that the origin. And so sometimes, I'm going to highlight this in purple, or sort of a pinkish color. Sometimes the x value, the y value, when x is 0, right there, is at the origin. And so then our y-intercept, which is written with the variable b, the y-intercept would be 0 in this case. So b equals 0. In this case, the trend line does not intersect with the origin. It intersects with a y value of 20. And so in this case, our y-intercept is 20. On this graph, we now have a negative slope, so we're going to have a very high y-intercept, because our x value, when our x value is 0, we have a y value of about 65. So here, b is 65. So once we know our slope and we know our y-intercept, we simply need to plug it in. So m in this equation is the slope. Whatever your slope is, you would just plug that value in right there. Your b in the equation is the y-intercept. So whatever your y-intercept is, you would plug it right there. We leave y and we leave x the way they are, and then we plug those in if we need to make predictions. For example, on the spaghetti bridges lab, x was the amount of spaghetti. So let's say we want to know the strength of 15 pieces of spaghetti. We just plug the number 15 in there for x, and then when we solved the equation, that would output the number of pennies that can support. And you can do that kind of thing with any experiment that we do in this class. And that's what's so great about y equals mx plus b, or point slope formula.